Firebase Remote Config. This is a cloud service. It enables you to change the behavior and appearance of your app. We said before that it's a third-party feature management service, meaning you don't really need to do anything. It offers everything out of the box. And it enables you to update the values through either the web-based console, but there are also backend APIs, so you can change values from your own backend. And the good thing is it supports a bunch of platforms, so you can use it across your stack. Hi everyone, thank you so much for joining me today. My name is Domen Lanishnik. I'm an Android engineer at Lyft, and today we're going to talk about feature flags. We're gonna take a look at what feature flags are, how they can help us, cover some best practices, and then we're gonna take a practical look at how to get started with Firebase Remote Config. So okay, let's first answer the question what the feature flag is. So a feature flag, in the most simple terms, is just a Boolean variable, but the most important difference is that it's controlled remotely. So that can either be via server, some like service or something else, and basically it enables you to enable or disable a feature in your app. So instead of having to rebuild the app and release it to get the feature out to users, you basically can just turn on a switch and the users have the feature enabled. So how do you do that? Well, here is a simple example, but let's say you want to add a functionality to the app to share some content. And the entry point to the functionality is the share button in the toolbar. So what you do is basically you put the entry point, in this case the toolbar button, behind the feature flag, so a Boolean variable, and then when it's turned off, the users don't have access to the functionality, and when it's turned on, they suddenly have access. So in terms of code, it's basically an if statement. And I know this looks like really simple, but we're going to learn later that this can be very useful, not just like to you as a developer, but to the entire company and product. So here in this example, so the string is actually the name of the feature flag, so it's called share feature enabled. The isFeatureEnabled function is just some function that basically checks on a remote service whether this feature is enabled. And then inside the if, it means that the feature is enabled and you can show the entry point. So in this case, the share button. But you can also do more complex things. So let's say you're introducing Jetpack Compose to your application and you're slowly migrating screens and the whole app to Compose. So because, if you're rewriting a screen from the old view-based system to the Compose one, you don't want to just replace the screen because you might introduce some new bugs that weren't there before and you might break something for users. So a kind of logical thing to do is to put the new migrated screen behind the feature flag, and that way you can release it to users. But then if you find that some error was introduced or the app is crashing because you missed something, you can simply disable the feature flag and the users get the old view-based screen, and then that gives you some time to kind of fix it. And with this, I also mentioned right now. So what feature flags help us do is, first of all, it decouples us from the release process. So let's say you're working on a feature with iOS. You are ahead of iOS, as usually the case is, for a few weeks. but the requirement from product or from wherever is that you release together at the same time. So in that case, you would have to have like the feature finished somewhere waiting for you to merge it into the main branch until iOS is also finished, and then you release it together, and then you need to time it and everything. But if you have the feature behind the feature flag, you can just merge it whenever you want to, and then once iOS is also ready, you just turn on the flag, and that's basically it. I talked about this before, but it helps you protect against critical bugs or crashes, because if you roll out some feature and then you start noticing that the app is crashing in this new feature, you can just disable the feature flag, and then buys you some time to kind of fix it in peace and then release the fixed version, and then you can wait for users to adopt, and then you can turn the feature back on again, and that fixes the issue. If you don't have a feature flag, well, at least based on my experience, what happens is, if the feature is important, you then notice that something is going wrong, then you kind of work overtime to do a hot fix and release it, and it's stressful for everyone involved. So developers, QA, product, basically everyone. So this is a great way to avoid this. And also, even if you do a hot fix, it can take a while for users to update to the latest version. So meanwhile, the app is still crashing for users who didn't update. So this is great. And then another one is you can control which users get the feature and when. So instead of like releasing the app and the feature to basically the whole user base, you can just target, let's say, 20% of users. You can gather feedback, like maybe there's some bug that's happening, maybe there are crashes, and then you can fix that before you release it to everyone else. And that kind of gives you some feedback loop. Another big one is developer velocity. So I know some like teams use feature branches. Basically, if it takes, I don't know, weeks or months to develop a new feature, they create a branch out of the main branch, and then they merge like different smaller chunks of code into that feature branch, and then once it's all finished, they merge it into main. So with that comes the pain of like having to keep that branch up to date, resolving merge conflicts, and then like finally merging that. And then, but then if you have a feature branch and the entry point to that feature, even if it's unfinished, is hidden from users, it means you can just merge directly into the main branch, because, well, the code is behind the feature flag, so the users can't access it. And that means that it's okay to have like not working or unfinished code in the main branch. And this also speeds up, because you don't need to like deal with the pains of feature branches. Good thing is also that you can have one-off features. So something like a marketing campaign or something really specific, like, I don't know, some Halloween promotion or Christmas promotion that just takes, I don't know, a few weeks, right? Instead of having to like release the version with that promotion enabled and then afterwards release another version to disable it, you just basically put it behind the feature flag, and then once the time comes, you turn it on, and after the promotion is run, you turn it off. Another benefit is that even when you turn it off, it's disabled for everyone. But if you like needed to push a new version out that has the feature disabled, and then the users don't update, it can happen that they see the Christmas promotion in March, let's say, because they didn't update it. Cool. Oh yeah, sorry. So the next one is, it the feature flags allow you to run A/B experiments. So there was a great talk yesterday about A/B experiments, but basically it allows you to divide your user base into 2 or more groups and then change some configuration between the groups and then observe which brings better results. So you gather some analytics and you can then see like the conversion rate and what makes users perform the desired actions. And then you can decide on the results whether you're actually going to ship the feature or not. Okay, so we talked about a lot of the benefits, but what are the drawbacks now? So, or what to watch out for, basically. So the first one is overusing feature flags. So each feature flag adds complexity to your code because there are more code paths to like read and go through and understand. And if you have too many, then it becomes hard to maintain. And it's especially hard when you have feature flags that are dependent on other feature flags, because then you have like combinations of different things. And if you have like a good code base and you're writing tests, then you also need to include the feature flag component into the tests. And then if you have dependent feature flags, it then just multiplies, because it's not enough to just have one test. You need to have at least like 2 tests, because you need to check what happens when the feature is enabled and what happens when the feature is disabled. So be pragmatic, like what you use feature flags for or how many you have, because they also can incur tech debt. So like in some of the previous examples, when I talked about migrating to Compose and having that behind feature flag, so let's say that it turns out that the new Compose screen is working great, and you release it to everyone, and then you kind of just forget about it. So you still have the old XML-based screen in your app. It's still used. I mean, like the code doesn't show up as unused because it's still referenced somewhere, but it's actually never accessible because the feature flag is enabled for everyone. So that's just basically dead code and tech debt. So you need to watch out for that. Cool. So yeah, some best practices. Definitely put new features under feature flags and ship early, so try to avoid those like long-lived feature branches and just merge straight into the main branch. It not only speeds up development and solves issues for you in terms of like merge conflicts and having to keep branches up to date, but it also enables you to get feedback early from QA, so they can try it out and give you some early feedback, find any issues. And then you need to define ownership for feature flags. So what I mean by that is each feature flag should have an owner, whether that is a team or some person that's responsible for that feature flag, and that kind of not only handles whether it's enabled or disabled, but also is responsible for doing cleanups and reviews for stale flags to avoid tech debt. And then I talked about this before, but try to avoid dependent feature flags because they just add complexity. And yeah, be pragmatic, like what you put under feature flags, because it's easy to get like carried away and start overusing it and put any fix under it. But yeah, try to be pragmatic. So okay, so far we've mostly covered Boolean feature flags, but there are also like other types. So you can have integer, strings, double, list. You can even have whole JSONs, and then what they become is basically remote configurable parameters. So you can change something in your app without having to rebuild the app. So this allows for different configurations, and you can target users with different values. So in this example, we have a card that shows a city, and below, in the bottom, we have a description text. So this is just a text composable, and the max lines property is actually a feature flag, or it's configurable. So then what that enables us is we can kind of run an experiment, and 1% of users see one line of description text and another see 3 lines, and then we can see, like, with the results, we can see what makes the users interact with it more. And this is a simple example, but you can use it for other things like handling refresh rates, how many times you retry network requests, things like that. Another type are kill switches. So kill switches are similar to Boolean feature flags, but they're used for critical paths. So we talked about having a feature flag and kind of disabling a feature with it. And kill switches are basically used for that. So let's say you're a banking app or something, and you introduce a new payment method, but then it turns out that it's not working, it's crashing, it can cost you millions in revenue if it's not working. You can simply disable or enable the kill switch, and that disables the feature. And okay, so the bad side is the feature is not working, but the good side is you're not like losing money because it's not working, and you're not losing users. So what's different between kill switches and regular feature flags is that they're refreshed more often. So usually feature flags are fetched either once per app launch or every few hours, because it's not as important that the user gets like the newest state. But with kill switches, it's usually that they are fetched like either, I don't know, every few minutes or sometimes even in real time, because it's important that the change happens as soon as possible. So yeah, we covered this, and the kill switch feature flag should not be the same as the main feature flag. This is mostly due to like because they're refreshed at different rates, and it can cause confusion, like you enable some but you forget to disable the other one. So yeah, A/B testing, we talked about this before. So if we have a feature flag, we can divide the user base into 2 groups, or even more if you need to. You can then gather analytics and metrics, and then decide whether you want to ship the feature. So in this example, it's in the top right we have a button. So on the left it's an icon button, on the right it's a text button, and then you can run an experiment and see what makes users click on it more. And this is a great way to get some like decisions based on actual data, so you can decide whether a feature is useful. Cool. So we've covered a lot of theory. Now how do you actually get like started using feature flags? So you have a couple of different solutions possible. So the first one is that you, as like your company or your team, you implement your own feature management service. Well, the drawback here is that this is a huge engineering effort. You need to create like not only backend services, but also some like user interface where you can update the feature flags, especially if product people are going to use it. And and then you have to maintain it, and it becomes really like difficult to keep this up and running. Plus, when you're starting out, you probably don't really know like what you're gonna use it for or what it will evolve in. So a better option is to use one of the existing open source libraries. So there are some libraries out there that handle all of this feature management, and you can use it and deploy it on your own servers, and that gives you a good starting point. The downside is still that you then have to maintain it yourself. So, and then the easiest way to get started is using a third-party feature management service. So this is usually like a cloud-based solution. Like we're going to talk about Firebase Remote Config later. You don't really need to do anything. You just kind of sign up, and it offers basically everything you would need out of the box, and it also supports advanced use cases. And then if you like encounter some limitations because you really started to adopting feature flags and A/B testing and things like that, then you can move on to like the earlier two solutions. So yeah, Firebase Remote Config. So this is a cloud service. It enables you to change the behavior and appearance of your app. We said before that it's third-party feature management service, meaning you don't really need to do anything. It offers everything out of the box. And it enables you to update the values through either the web-based console. So you have some UI and you can easily update it. But there are also backend APIs, so you can change values from your own backend. And the good thing is it supports a bunch of platforms, so you can use it across your stack. So yeah, then how do you set this up? So the first one, it depends whether you're already using Firebase in your app or not, but you need to set up a new Firebase project. Then you need to integrate the Firebase SDK into your app. That gives you access to the remote config object, which you then configure. Then you need to fetch and activate the values. Then you need to read the value for each feature flag from the object you've configured earlier. And then optionally, you can also listen for updates in real time. So we're going to take a closer look now into every one of the steps. So the first step is to set up a new Firebase project. Now I'm going to go quicker through this because I'm sure most of you are already using Firebase in your app, at least Crashlytics. But yeah, basically you create a new project. If it asks you, you can turn on Google Analytics. It's not required, but it's needed if you want to do A/B testing and you want to target some specific user properties. Okay, then to actually integrate the SDK, you need to define your package name. You need to provide the fingerprint of your app, so it's more secure. And then that generates a Google Services JSON, which you add to your app. And that just allows your app and the Firebase to kind of make sure that they're talking to the correct app and service. And then the next step is you need to add the Google Services Gradle plugin to your project level build file. After that, you need to add the Firebase specific libraries or dependencies. So that would be the Firebase config dependency. So if you're already using Firebase for Crashlytics, then you just need to add this config dependency. And then also, if you want to use A/B testing, you can add the Firebase analytics. So once you have that, you're kind of set up. And if you open the Firebase Remote Config console on the web, it will ask you to create your first parameter. So a parameter is what Firebase calls feature flags, basically. It's just some variable that you can change the values. So by default, the data type is string, but we want a Boolean type because we want a feature flag. So we then change it to Boolean, and we enter the name of the feature flag. In this case, it's detail screen enabled because we want to add a new detail screen. And so we've defined a new feature flag here. You enter a description, and then you set the default value. So we want it to be disabled by default, and then we're going to overwrite it later. There's also a little switch there which says to use the in-app defaults. So we're going to take a look later, but in your code you can define default values, and if you enable this switch, the Firebase is going to use those values instead. And then once you save the first parameter, you have some unpublished changes. And if you want to make them accessible, then you need to publish those changes. And then once you do, they're available to your clients. Cool. Okay, so let's jump into the code now. So we've added the dependencies, and now it's time to initialize remote config and configure it. So this, where you put this code depends on your app architecture. If you take a look at the Firebase documentation, they simply add it to the main activity, but I would really recommend that you put it into some wrapper class. Here we have a feature checker, so that you can then inject it wherever you want to use it, whether that's in view models or some other parts of your app, depending on your architecture. So, okay. So anyway, wherever you put it, first thing you need to do is you need to get the singleton instance of Firebase Remote Config, and you need to set it up. So there's a good Kotlin DSL available, so instead of having to go through builder patterns, you can just use the remote config settings builder, and what we are doing here is we're setting the minimum fetch interval in seconds. So this means that Firebase will try to fetch new values every hour. Now for testing, you can put even lower number, but for production, you need to watch out. So I think 1 hour is kind of the minimum, because if you go lower than that, then Firebase will start throttling you, and then you will be, then it will turn on the default refresh time, which is 12 hours. So watch out when you're testing this. And it also supports a bunch of other settings, but this is the most important one. So after that, we simply set the config settings. Now another thing we need to do is to set the default values. So because Firebase needs to, the SDK, needs to call the Firebase remote service to fetch the values, and that's a network request, it takes some time before the values become available. So to avoid situation where you don't have values, you can define your local client defaults. So you can either do that as a map in Kotlin, or you can also define it in XML and provide a reference to the XML. So here we have the first feature flag that we created the parameter earlier. We have another one that's long type, and then another one that's a string. Cool. So once you have all of this set up, what you need to do is you need to fetch the remote values. So then you need to decide when you're going to do that. So you have a few options. First one is you fetch the values from the service during app startup. So if you have a splash screen, you can do it there, and then after it's fetched, so like after the splash screen, you have the newest values available to you, and you can immediately use them. Another option is that you do this fetching in async way, so you basically fire it and you forget about it, and then you like post some updates through either a flow or something else to other parts of your app, and then you update the UI. This kind of depends on your use case, but usually it's kind of bad from a UX experience if the user is watching a screen and then something immediately shows up. So, but then what's also acceptable is if you fetch the values and then use them the next time the app is launched. So it depends on like the feature and how important it is and so on. And here is a simple function that we would define in the same class as earlier, which is basically to fetch the features config. So this is like Firebase allows you to do this in multiple different ways. So this is an example how you would do it if you use coroutines and you have a suspending function. You basically call fetch and activate and then await. But if you want, you can also use the listeners. So you would call fetch and activate, and then you have a bunch of listeners for success, failure, and so on. So it depends on what you're using. And then once you have the values fetched, then you can actually start reading the value of your feature flag. So this is like a simple function that you write. It's just a wrapper around the remote config get boolean function. And you would call this from your view model, basically, or from anywhere else you want to check the value of a feature flag. And if you want to like read some different types like long or strings, you can do it like that as well. So then if we take a look, so here we have a view model. We inject the feature checker class that we defined earlier, and we have basically some state flow that just says, well, that basically tells the UI whether it should show some entry point into the details screen. And then what we're doing is we're basically emitting the value of the feature flag. So we're calling feature checker is feature enabled, and we're providing the feature flag. And then in our UI, you would kind of collect the value of the feature flag, and then you would change the UI depending on what's happening. So here we're kind of showing the details button in the top right because the feature flag is enabled, and that allows kind of the user to click on it, and that opens the details screen. So while the feature flag is for the details screen itself, which you're building, we're only like showing and hiding the entry point, right? Because if there's no entry point, then the users can't access it. So we talked about kill switches earlier, and that they are updated more often. Well, Firebase allows you to do that. So it allows you to receive new values as soon as they are published on the console. It does that by kind of opening an HTTP connection to the remote config backend, and it has some like smart cache invalidation logic. And basically once you publish updates, it will push the values to you. So how do you do that? So again, you have this function inside your feature checker class, and basically we've converted it to a flow, but because Firebase only provides like callback based solution. But basically what you do is you put a add-on config update listener to the remote config object, and then gives you access to the onUpdate callback. So onUpdate is called when you publish new values on the console, and then you get a callback. And what you then need to do is you need to actually activate the values first. That kind of stores them locally, and then after that you can use them to update your UI or anything else. So important thing is that what you get here are basically the keys of the flags that were updated, and then you can basically check whether the flag you're interested in changed. So how would you use that? So inside the view model, you could observe the config changes, and if the your feature flag that you're interested in changed, then you can emit the update to the UI and update it. Or in case of a kill switch, you can disable some logic. How this looks like in practice is immediately as we publish changes, the UI updates. Okay, so we talked about earlier about targeting different users, and you can do that on Firebase by defining a new conditions. So a condition is basically just a filter, and here we're creating a filter for just Android. So if you want to enable some feature just for Android, you basically define a new condition, and then when you are creating your feature flag, you add that condition and you set the value. So in this case, the default value would be false, but it would be enabled for all the Android clients, while iOS and others would have it disabled. You can also target a random percentage of users, or a percentage of random users, so 20%, for example. And you can also define for promotions during which time the value should actually be enabled. And after this expires, the value will automatically go back to the default one. Okay, I'll go quickly through this. So some other capabilities of Firebase are the A/B experiments. So there's a tab there, you can run experiments. And it also supports some personalization, meaning you can use machine learning to deliver some custom experience to users. And then to some limitations, so it's free to use for unlimited daily active users, but you can only have up to 2,000 parameters or feature flags. And there are some limits on how long each name of the feature flag can be. You can have maximum of 500 conditions. And I said this before, but if you define the refresh rate and it's too low, you're gonna get throttled. And then for A/B experiments, you can have maximum up to 300 A/B experiments, and 24 of them can actually be active. Cool. So yeah, so to kind of summarize everything, feature flags, I hope it became clear that they can be really powerful, not just to you, but also to your company, because they can make you move faster and be safer when something goes wrong. And there are some drawbacks, but I would say the benefits are much better. And it's really easy to get started. If you want to get started, you can use Firebase Remote Config. You just need to add some dependencies, do some config, and you're basically up and running. And you have one class and you can use it across your app, and it's a really easy way to get started. And yeah, also stick to best practices, and yeah, that's it. Thank you so much.